on AP tests. But again, it's just something I show you just because it's part of the curriculum, it's part of the standards, so take with that what you will. Now on our test, for this chapter test, when we take it, there'll probably be a question on there. There'll probably be one question on the multiple choice about this, so it'll be important for you guys, but in the grand scheme of things, you know. So what are inverses? Inverses are functions that have their domain and range swapped. What are domain and range? X and Y. So if I swap positions, if I swap x's for y's, that's what the inverse looks like. So each function has an inverse, okay? Well, not each function, but the functions that do have inverses, that's what we do, okay? How do you know they're inverses? Well, there's a couple ways to tell. First of all the x's and y's are swapped. So if you have a table, all the values are swapped. If you have a graph, so if you have two graphs and they're symmetric over y equals the line y equals x. So the line y equals x looks like this. So there's the xy, right? The line y equals x is the diagonal line that goes through 0, 0 like that. That is y equals x. So if you have a function, two functions, and they mirror each other across that red line, they're inverses. So that's how you can tell graphically, okay? Another way to tell is if you put one function inside of another function and simplify it, all you'll be left with is x. That's another way to tell, okay? So for f to have an inverse, so for a function to have an inverse, it has to be 1 to 1. So 1 to 1 means, so you guys remember in Math 1, they teach you about the vertical line, the pencil test, the vertical line test to see if it's a function. You run it over, and then if you hit the pencil in more than one spot, it's not a function. So like the red line is a function, but something like this, isn't a function, because if I were to run my pencil over it, I'd hit in multiple spots, right? That's the vertical line test. It's the test to see if it's a function or not. Well, 1 to 1 means it passes the horizontal. So you just flip your pen the other way, okay? So for it to have an inverse, it has to pass the vertical line and horizontal line test. So the ones that do not have inverses, the most common ones are quadratics, because they pass the horizontal line test, or the vertical line test, right? But they don't pass the horizontal line test because it hits in multiple spots. The other ones are anything, so x to the 4th looks like this, x to the 6th, x to the 8th, all. So if your biggest power is even, it's not going to pass the horizontal line test. So the only things that have inverses are linear, x to the 1st power, cubic, x to the 3rd power, anything x to the 5th power, x to the 7th power, x to the 9th power, those things like that, okay? So, yeah, so that's what that means. Monotonic, I don't know how to pronounce that, always increasing, so something that's always increasing or always decreasing. Lines, has to go one or the other, right? Either increasing or decreasing, right? If it's a constant, it's not doing either, so that one does it. Quadratics, they decrease and increase. Same thing with x to the 4th, right? So anything that does multiple things, increases and decreases, anything that does both won't have inverses. That's what monotonic means. And then we use this notation, the little -1 power. That notation means inverse. Okay? So that's background. So in Math 3, we talk about inverses. Okay? So in Math 3, we talk about how to find an inverse. Okay? So it's not a calculus topic, but it is important to know how to find an inverse. Okay? So if we have a function like this, first thing we do is we always swap x and y, right? F of x just means y. It's equal to y. So the first thing we do is swap x and y. And then we solve for y. Subtract 2 from both sides. Divide by 6. We get y equals x minus 2 over 6. Right? So these two guys are inverses of each other. They are inverses of each other. They're both linear, so they have inverses. Okay? The other thing is, look at f of x, the original f of x. What operations does it have? Which are the 4 operations? Adding, subtracting, multiplying, or dividing? Adding, right? Plus 2. And what else? 6 times x, right? So it has multiplication and addition, right? Its inverse. What operations does its inverse have?
I see. Subtract and division.
Subtract and division, right? The opposites, right? In the original, f of x, you're multiplying times 6, right?
Yes.
What are you doing in the inverse? Dividing by 6, right? And in the original, you're adding 2. What are you doing in the inverse? Subtracting by 2. It's just the opposite, right? Inverse, that they call it inverse operations. That's where it comes from. Okay? So you have something that's a square root. Okay? So square root x minus 5 equals 3. So the inverse, so I'm not going to find it yet, but I know the inverse, since this one has a square root, it has subtraction inside, and it has addition outside, right? So I would expect, what's the inverse of, the inverse of addition is subtraction, right? So I would expect it to have minus 3 somewhere. And then the inverse of subtraction is addition. So I would expect it to have plus 5 somewhere, right? And then what's the inverse of square root? Squared, right? So I would expect it to have a squared somewhere. Okay, that's how you kind of can check your answers. So let's flip x and y, and then solve. Okay, so we subtract 3 from both sides. There's our minus 3 that we were talking about. So we have x minus 3 equals the square root of y minus 5. I can't add 5 yet until I get rid of the root. So to get rid of the root, I have to do the opposite, which is squaring, right? We just talked about that. So that's y minus 5 equals x minus 3 squared. Now I can add 5 to both sides. So its inverse is x minus 3 quantity squared plus 5. Okay, that's how to find an inverse. Okay, they won't ask you in this class to find an inverse. All they'll ask you to do is say, hey, here is a function. What is the derivative of its inverse? One way to do it is to find the inverse and then find the derivative, right? That's one way to do it. But some of these sometimes it's not that easy to do that. So they give us other methods for finding the inverse, which is down at the bottom. Okay, so there's 2 ways to find an inverse, to find a derivative of an inverse. One when they give you tables. So the green on mine is when they give you tables. Okay, so if they give you a table of values and they want you to find the derivative of an inverse, well, first of all, it's kind of hard to find the derivative of a function when you don't even know what it is. That's when they give you tables. Okay, so we're going to use that guy. Okay. The bottom one and the steps to the right is when they give you an equation. They actually give you an equation. They say, here's the function. The function is x squared plus 3x minus 2. Find the derivative of its inverse. When that's the case, we use these steps. Okay, so when you actually know the function, I know what f of x is. I know what g of x is. I know what h of x is. When you actually know it, you're going to use the magenta color. When you give you a table, when they give you a table of values, that's when you use the green, that one. Okay? So we're going to go through these. We're just going to do a couple examples and we'll decide which one are we going to use. Is it the equations one, steps? Do I use the 4 steps there? or do I use the, they both do the same thing. They both do exactly the same thing. The reason I say use one with equations and use one with tables is because it's easier. It's easier to do those steps. It's easier to use the green when you're dealing with tables. It's not so easy to use the green when you're dealing with equations and vice versa. Okay, can you do it? Yes, but keep it easy. Keep it as easy as possible. Okay? Okay, so let's take a look at one. Let's look at example number 2 on the back. Okay? So find the derivative of the inverse functions. So we have f of x, right? We know what f of x is. It's x cubed plus 4x plus 2. Okay? They want us to find the derivative of its inverse, right? It has an inverse because it's x cubed. It's a cubic. They want us to find the derivative of its inverse and then plug in -3. Okay? So could you find its inverse and then do the, like we did on the first page? Yeah, but sticking to the steps is a little easier because it's kind of tricky to find an inverse when you have multiple x's because you have to isolate them and it gets to be a little too much. So this one has an equation, right? We know what f of x is. X cubed plus 4x plus 2. They told us. So we're going to use the steps. Okay? Now the steps, the letters are interchangeable, right? It says for g of x equals blah, 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 g, they use g, they're interchangeable. So it just depends on what letters they're using, okay? So the first step says set f of x, right? G of x in this case is the inverse. I don't know what the inverse is, right? So I'm going to set the original equal to the a value. So look on number 2. What is the a value going to be? -3, right? The guy that we need to find, right? That's the x value, -3. So what we're going to do is we're going to set f of x equal to -3. Okay? So we have x cubed plus 4x plus 2 equals -3. Okay? So now we got to solve it. What is x equal to? Well, the easiest way to do this is just by guess and check. That's the easiest way to do this. So what number would I plug in for x? What number would I plug in for x? Oops. Here and here. That would give me -3 as an answer. Kind of some mental math. So what number, when I cube it, and then add 4 times that same number, and then I add 2, would give me -3 as an answer. -1. -1. -1 squared is -1, or cubed, sorry. -1 cubed is -1. And then positive 4 times -1 is -4, plus 2 equals 3. Okay? When you're doing these, it won't be a crazy number. It's not going to be like -1.6. It's going to be like -1, +2, +3, -6, things like that. It'll be doable numbers. Okay? All right, so we know x equals -1. That's step 1. Okay, so let's go to step 2 now. Step 2 said, find f of x. Its derivative. So what would the derivative of f be? (3x squared) keeps going. Plus 4.
4.
There you go. That's step 3, or step 2. Step 3. Find f prime of whatever answer you got in step 1. Okay. So now we have to find f prime of this guy here. So plug in -1 into the derivative. We get 3 plus 4, which is 7. Okay. That was step 3. Step 4, flip it. What would 7 be flipped? 1 over 7. That's our answer. Okay.
I don't like this one. I'm not too familiar with it.
Okay. All right, so let's try B. Let's try 2B.
2B.
Same setup, right? Same setup. We have f of x. They say g of x is its inverse. Find g prime of 1. So they're saying they want the derivative of the inverse, plug in 1. Okay? So first step here. First step is set this guy equal to a, the a term, right? This is the a term here. So what number would I plug in for x that would give me 1 as an answer? Let's see, 2 cubed is 8. Let's see. 2 cubed is 8 minus 7 is 1. The square root of 1 is 1. Yep. So x equals 2. Step 2, find the derivative of f. Well, f is the square root, right? So we're going to write it like that, to the 1/2 power, right? Now we got to find the derivative of that guy. Well, we're doing chain rule. This is pretty tame compared to the ones you guys did on your quiz with chain rule. You guys can handle this. Move the 1/2 to the front, rewrite, subtract the whole power, chain the derivative of the inside, right? So we had derivative of the outside, which is something to the 1/2 power, and then derivative of the inside, which is 3x squared. That was step 2, sorry. Step 3 says f prime of that number that we got in step 1. So f prime of 2. Okay. So I'm going to go 1/2 parentheses x cubed minus 7 to the negative 1/2 power times 3 times x squared. So everywhere there, I'm going to plug in a 2. So we got 1/2. I'll do parentheses first. So we get 1, right? This is just 1 to the negative 1/2 power. And then over here, I get 2 squared is 4 times 3 is 12. Exponents now. What does negative 1/2 power mean to do? So if I say something to the negative 1/2 power, what is that in plain English, what does that mean to do? Square root and then flip it, right? Square root and then flip it. So what's the square root of 1? 1. And then if I flip 1, reciprocal, it's still going to be 1, right? Good. So we got 1/2 times 1 times 12. That's going to be 6. Step 4, flip 6. Done. Okay.
Table.
All right, so here we go. Let's try this one.
Wait, that's the other one, right? 1 over the derivative of the inverse. Okay. Oh.
Okay, so yeah, let's go to the table next. See, this is the table. So we're going to use the other version that we didn't get to use on the last two problems, this guy right here. So believe it or not, these say the same thing, just without the steps, okay? So f of -1 means an inverse. So we're finding the derivative of an inverse at a specific number. That's what we're doing, okay? So to do that, we got to go 1 over, and then on the inside we have the inverse, and then we have the derivative of that inverse, okay? So let's set that up.
I understand.
Okay. Let me write this on the board so we don't have to keep going back and forth. So x equals 1 over f prime x. Okay, so we're going to fill in these things with things we know. So let's go back to our C. Okay. The table below gives selected values for the differentiable and decreasing functions. So we know it's differentiable. Differentiable just means it has a derivative. Whatever f is, it has a derivative, okay? And decreasing means it's always going downhill. Remember, it's not, if it changes at all, it doesn't have it won't have a inverse. And it's derivative. If g of x equals the inverse of f, what is the value of g prime of 6? Okay. So remember, the inverse, right? The inverse is equal to g of x. So the inverse of f, I don't know why it's blurry, but there we go. They said that, right? So when I say g, I mean f's inverse. Okay, you don't have to, they're both the same, okay? So when I say g prime of 6, that means the inverse, all right? Okay, so here we go. So we're going to find g prime of 6. Okay. We're going to put a 1 over that, because anytime you see this guy, anytime you see f to the -1, it's also g. Okay. So f prime, I could put g of 6, but I'm going to leave it as f because it goes with the table. Okay. It goes with the table. So could I have changed f the inverse, f -1 to g? I could, but I'm going to refer to the table, and there's no g's in the table. Okay. All right. Okay, so now the first thing we do is the inside. We always start on the inside in math. The inside parentheses. So the first thing we got to do is figure out what that is. So in basic English, in plain English, what does that mean? Because if you can know what it means, you know how to find it.
The inverse of 6.
So the inverse when x,
6.
so it's the inverse, right? And what do we do with x and y when we do inverse, when we find inverse? We swap them, right? On it. So if it said, let me show you this way. Maybe this will make more sense. If I said f of 6, just regular f of 6, what does that mean?
X is 6.
When x is 6, what is y, right?
So are we asking now when I and y is
When y, now this was actually the opposite question. When y is 6,
Oh, I understand.
x is what? That's what it's asking.
Okay.
It's just asking the opposite question of a question you've asked yourself many, many times. Because it's an inverse, right? F of 6 means, okay, x is 6, what is y? F inverse of f means when y is 6, what is x? Okay, so let's answer it.
Uh-oh, I blurred again.
When y is 6, let's see if I can get it blurry. There we go. What is x? Look at the table.
-3?
Yeah, -3. This is the y's, right? This is all the y's here, because another f of x is y. Right? This is y prime. Right? So y is 6 at the top. So when y is 6, x is -3. So we're going to put -3 in there. Okay. Now what is f prime of -3? Yep, -1. 1 over -1, which is just -1. So g prime of 6, which is the same thing as f -1. Oops.
I understand.
Equals -1. Okay, so when we talk about inverses, it's just flipping the question you guys have been asked for years, right? When x is 6, what is y? Well, now it's flipping that question to say when y is 6, what is f? Or what is x, okay? Why it's blurry.
Okay,
Okay,
and we're immediately back to the question.
all right. Let me give you,
Darn.
all right, D, let's do D. Let's do D and then we'll see what's what.
Number trig?
Okay.
No, D. Should be on D.
Okay, so the function f is defined, they give us f, and they give us a point on f. So that point is on f. It's not on the inverse, it's on f. Okay? And again, g is the same as the inverse of f. What is the value of g prime of -6? Okay? So they've given us the equation, right?
We have to do the steps.
So this one we're going to have to do the steps, yeah. So step 1 says,
Okay.
step 1 says find what f of x, set f of x equal to a. So -2x cubed minus x minus 3 equals -6. So mental math here. What number would I plug in for x? That would give me -6 as an answer. +1. It's going to be +1. 1 cubed is 1 times -2 is -2, minus 1 is -3, and then minus 3 more is -6. Okay, so x equals 1. Step 2, find f prime. F prime is -6x squared minus 1. Step 3, f prime of the same number we found in step 1. So we have -6, 1 squared minus 1. -6 minus 1 is -7. Step 4 is the easiest step. Flip it. What would I get if I flip -7? Yep, -1/7. Okay. Let's see. All right, so let me give you, I'm going to give you one problem like that, and then I'm going to give you a table problem. And then we'll go on if we have time.
What was the, why did the question even have the point?
That's a good question. I don't know why.
It's just this scary. They're trying to spook you.
Yeah, we didn't need it.
All right, so this makes this one E.
I know why. I know why. Because you could have used the other method. You could have used that method. Yeah, you could have used that method to do it.
No.
Because,
Oh, the one is.
yeah, because x and y, 1, -6, right? You could have done that method if you wanted to. But keep it easy. Keep it easy. Keep it simple. Okay, so here we go. Right next to D, let me give you another one. So we'll call this E.
Go back to it. Oh, okay. So there you go.
Okay, so here we go. F of x. F of x is -x² plus, or sorry, x third. Sorry, -x³ plus x squared. Minus 4x. That's f of x.
A lot of numbers.
The inverse of f is also known as g. Find g prime of -4. So step one, set it equal to -4, that's 1. So when you plug in 1, 1 cubed is 1, times -1 is -1, plus 1 is 0, minus 4 is -4. Find the derivative, plug in 1 to that derivative, flip it, you're good. Okay, all right, so now I'm going to give you one
This F now?
on here.
Bro, it's just a delta math.
Yeah, it's a
Alright,
delta
so
math.
we got, okay.
There we go.
Let me write this paper down.
So yeah, you don't have to write down the whole table, just write down the parts that are important, the parts that you end up using on the table, the points that you end up using, kind of like the last question where it just gave us that 1 point that we would need. Okay. All right, so we have this guy here, it's a table, so we're going to use this part here. 1 over f prime f -1 of x. Okay, that part here. All right, so the first thing is since they don't even use g for this guy. Okay, so we're going to find this guy here. First thing we do is plug in 4 for x. Then we start. So always start on the inside, right? So which question is this what question is this asking here? What is x when y is 4, right? X equals what? So when y, this is the y's, this is the y primes. When y is 4, what is x? -4, right? So then we go 1 over f prime -4. That's just 4, right? Where's it? Oh, sorry, I looked at the wrong list. Sorry. I looked at the wrong one. -2, yeah. -2, sorry. Okay. So that's when we get a table. All right. Okay, so I'm not going to go on to trig. The other inverse is trig. It's not hard, but I just don't want to go over it because we only have about 10 minutes and it'll take a little bit over 10 minutes. So today we'll stop there.